Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we are going to be wrapping up the 2024 January resit examination paper that was just recently concluded in 2024. That is in fact January the 4th, or I think it was January the 5th. Now, of course, you would have already seen 3 of our uploads. Upload 1 was where we discussed questions 1 to 3. Upload 2, we discussed questions 4 to 7. And of course, upload 3, we discussed questions 8 all the way to question 9. And of course, that was quite of an intense video. Lots of stuff was discussed in that, so I do recommend that if you are in fact watching this video for the first time, then it would be highly recommended that you go ahead and check out part 1, part 2 and part 3. Now, I've decided to do the video like this because of course I don't just want to provide you with the solutions, but I also want to develop your analytical thinking. So I take my time and I go through all the little things that you need to be asking yourself when you're approaching questions of similar nature. Alright, so definitely highly recommended that you go ahead and check out those other 3 parts for 2024. I'll definitely be doing a series of videos for you as it relates to past papers. So I'll be doing a compilation of questions 1, question 2s, question 3s from different years, January and May, to give you as much resources as you possibly can get to be prepared for the exam coming up. All right, now of course, if this is the first time here on the channel, feel free to subscribe to the channel and grow the family of mathematicians, future mathematicians. Of course, do not forget to leave your positive questions and comments down below, your suggestions, how I can make it easier for you to for your math preparations. Of course, leave a like if you have gotten some sort of value from the contents being posted here, and of course, do not forget to hit the like button. It really does help the channel to grow. So let's just jump right into it and begin this final upload of the 2024 January resit paper. Now, what I've decided to do here, guys, for this particular paper here, for this particular upload, I've decided to go back through question, say here, let me scroll up. I think we were doing, this is in fact question 8. So I've decided to go back through the graphical part of question 8. I've kind of felt, after watching the editing process of that video, I kind of felt like I didn't really give you guys a good, clear explanation on how to approach the completing the square problem. So I'm going to be taking it from here and I'm going to be wrapping up the whole entire paper for you in hopefully less than an hour of this video. All right, so we're going to be starting the explanation from this question here. All right, now the very first thing here that we're looking at is, in fact, we are required to write 4x squared minus 24x plus 31 in the form a open bracket x plus h all squared plus k. Now, in completing the square, there are 3 particular values that we need to place our focus on. And those values are, in fact, finding the value of a, finding the value of h, and finding the value of k. Now, what I'm teaching you here is a shortcut method in terms of completing this square. Now, there is a technique for doing this, but in this shorter version of completing the square, I believe CSEC only requires you to state the values here. So to find a is not particularly a value that you have to calculate. A is more of a value that you have to just basically observe. So when you're given a quadratic equation such as 4x squared minus 24x plus 31, then your value of a is in fact the number that appears before the x squared. So in this case here, right away, that a is in fact 4. Now, there is a formula that was derived by completing the square for the quadratic format. By completing the square, we basically will see here that the value of h is in fact b divided by 2a. Now, I do not have a tutorial on this of how to derive these formulas, because that is more like for advanced students. For CSEC, the requirement for deriving the formula, I've not yet seen that as a question on the exam paper. So we just pretty much, it's a case where you just grab the formula and go. Now to find h here, it's going to be required that the value of b is in fact the number that appears before x. So that is in fact negative 24. All right, and then we're going to divide that then by, say here, 2 times the value of a, which in this case is also 4. So when we work this out, we find that h then is equal to negative 24 divided by 8. 2 fours is 8, so h works out to be minus 3. And if you want some more clarity on how I'm getting my A values, my B values, and of course you're going to see over here my C value, then you can visit the link that is pinned in the comments. That will take you to 2 particular videos: the introduction to the quadratic expression, and also you could watch the video on how to solve quadratic equations. So that is how I'm getting my values of A, B, and C. Now here you're seeing here that the formula for finding the K value here is in fact 4AC minus B squared, all divided by 4 times A. So therefore then, what we're looking at then is in fact K then works out to be 4 multiplied by the value of A, which is in fact 4 again, multiplied by the value of C, which is the constant 31. And then therefore now we're going to be subtracting the value of B squared from that. So that's going to be negative 24 squared, and that's all B divided then by, say here, 4 times A, which is 4 times 4. Now once we go on our calculator here and we type in 4 multiplied by 4 multiplied by 31, we will end up with a result here of 496. And when we go ahead then and we square negative 24, we're going to end up with 576. And that will all be divided by, say here, 16. 4 times 4 is 16. Now when you work this out, 496 minus 576 will result in negative 80. And that's going to be divided then by 16. So easily then we end up with a K value here, which is equal to, say here, negative 5. So now we can just kind of highlight our answers. A is in fact, say here, 4. B works out, pardon me, not B, H here works out to be minus 3. And then of course C, K here works out to be negative 5. Now with that, we can therefore draw a conclusion by saying that the expression given, 4x squared minus 24x plus 31, is in fact identical to, and as they say here, place the value of A, which we know is 4, so that's 4, open bracket, x will remain as x here, but then the h value we had calculated is in fact minus 3, h equals minus 3. And so therefore then K then works out to be negative 5. So we have a negative 5 at the end. And then this basically represents 4x squared minus 24x plus 31 written in the form A open bracket x plus h all squared plus k. Our answer is then therefore 4 open bracket x minus 3 all squared. Pardon me, I left off my square here, minus 5. All right, and that is how you complete the square using the shortcut method then. All right. Now, beautiful. Let's go on here then to look at the part 2 to this question. Now, it says on the axis provided, which you can see here clearly, they have provided you with an empty axis. You're to sketch the graph of 4x squared minus 24x plus 31, indicating the coordinates of the maximum or minimum point and the y-intercept. Now, when it comes to sketching a graph, what we need is just a kind of resemblance of what the graph would look like if we were given a table of values. Now, when it comes to sketching the graph, we're pretty much looking at, in fact, finding a couple terms here. Now, let's just write them down here. What are we going to need? So number one, I always tend to want to find my y-intercept value first, okay? Which is kind of like what they're asking you for. So I want my y-intercept value. I'll let you know how you calculate that in a moment. I'm also going to need what are known as the x-intercepts. This is more than one. So my x-intercepts, or what you're going to find sometimes in certain questions, they will refer to as the x-intercepts as the roots of the quadratic equation. And then you're going to look at finding what is known as your minimum point. So your minimum point. All right, your minimum point. And that's the lowest point or the maximum point. In this case, it's a minimum graph because it's a positive curve. So I just wrote minimum point here, but it could also be maximum point depending on the quadratic equation or the quadratic expression. So now once we've done that, then it's now time for me to tell you how do we actually predict or estimate these values. Now my y-intercept here is what we most commonly refer to as the C value in the quadratic expression format. Now, if you know anything about quadratic expressions, you'll know that the general form of a quadratic equation or expression is in fact ax squared plus or minus bx plus or minus c. So the constant at the end, that number that is all by itself, usually represents your y-intercept. Another way to actually calculate your y-intercept is replace the x in the equation with 0. So here we have this expression here. You could replace the x with 0, replace the x with 0 here, work it out, and you're going to find that your C value or your y-intercept is 31. So we kind of just don't do that. I kind of just let you know that the end number here, this constant, is always your y-intercept. Okay, so in this case here, we end up with C being equal to 31. In a moment, I'll show you how to put that on the graph. Now your x-intercepts are what is referred to as your roots of your quadratic equation. Basically represents the point or points at which the quadratic curve is going to cross the x-axis. So it could cross it over here and over here, or it could cross it both on this side, or it could cross it both on that side. So you could have a graph that looks like this per se, or you could have a graph that looks like this per se. So both intercepts on the left side of the x, or both intercepts on the left side of the, or the right side of the x-axis, or it could be a case where we end up with a graph that pretty much crosses both sides of the axis, something of that sort. Okay, so it could be any one of those three. And for us to determine that, we are going to need to find the x-intercepts then. So how do we actually find the x-intercept? We find the x-intercept by a couple of methods. You can actually go ahead and complete the square. You can solve the completing the square equation that is up here. Or you can go ahead and use the formula minus b plus or minus the square root of b squared minus 4ac all divided by 2a. That formula you can see in the formula sheet provided to you on your question booklet by CSEC on a yearly basis. Just go to the front of the page or the document and you will be able to find, say here, the quadratic equation for finding the roots, or finding the formula for finding the roots of the quadratic equation. Now I'm going to try to use what I already have to help me. I don't want to use any additional formulas then. So now that I have cleared my graph here for you, let us begin the process here. So as I said before, the y value here, we had established that the y-intercept in this case, so that's my y-intercept, that's going to be equal to 31. So because it's a sketch, all we have to do is just make an estimate as to where 31 might be. So this is 0. We can just estimate that 31 is going to be at the highest point here. That is in fact 31. Let me just write then the 31 on this side here. So this would be my 31. That's just my estimated point. That's 31. Now, as I said, to find the equation, then we can therefore take, say here, 4x squared. Pardon me, that's not what we had. All right, so I've already completed the square, and the result that was provided was in fact 4 open bracket. So that was 4 open bracket x. I think it was minus 3. Was it? I think it was, yes, I think it was minus 3. And we had, and that is all squared. And then we had actually worked out the k value to be minus 5 as well. So that was the equation that we got. Now, as I said before, I kind of want to just use all the work that I've already done. I'm just going to therefore go ahead and equate the equation to 0. And I'm going to solve this equation. Now, remember, that's what we're looking for, is the x x-intercept. So we're looking at what point did it cross the x-axis. So to do this, then we have to go ahead and carry the 5 over here. We're going to end up with 4 open bracket x minus 3 all squared, and that's going to be equal to positive 5. Now I'm going to isolate the bracket, the x minus 3 all squared, by dividing both sides by 4. So when I divide the left side here by 4, the 4 is going to cancel. So I'm going to be left with x minus 3 all squared. And of course, I'm going to divide the right side by 4. So I'm going to end up with 5 over 4. Now, in order for me to get inside the bracket to get access to the x, I'm going to have to square root both sides of my equation. So when I square root the left side here, the square root will in fact cancel the square. We've discussed this in my changing the subject of the formula video. You can see that pinned in the comments below. So you'll see that link in the description. You can therefore go ahead and check out how to remove the powers from an expression. So when I square root the left side here, I'm going to end up with x minus 3. And that's going to be equal to, of course, when I square root a value, I'm always going to get plus or minus, say here, the square root of 5 over 4. Now, I can therefore then go ahead and subtract, pardon me, I can add 3 to both sides, or some instructor will say transpose the negative 3. So you end up with the formula that x is equal to positive 3 plus or minus the square root of 5 over 4. Now we can go ahead on the calculator and we can therefore say find the square root of, say, 5 divided by 4. All right, you can divide 5 divided by 4, you're going to get 1.25. And when you square root 1.25, you'll find that the answer then works out that x is equal to 3 plus or minus 1.1. Now I need to get 2 solutions, so therefore one of 2 things are going to happen. Well, not one of 2, both of these things are going to occur. X is going to be equal to 3 plus 1.1, or x is going to be equal to 3 minus 1.1. So therefore then we're going to work out that x then is equal to, say here, 4.1, and then it also works out that x is equal to 1.9. And so those 2 values then therefore tells me, the student, that I need to estimate where 4.1 is going to be. Now of course here I can just label whatever. I can just say here that is 1, this is 2, this is 3, this is 4. Remember, it's a sketch. This is, say, 5. It doesn't have to be accurate. So if this is 1 and this is 2, I know that 1.9 can therefore be very, very close. It's almost on 2, but it's very, very close here. Very close knitted right there. And then now, of course, 4.1 is going to be, this is 3, this is 4. So 4.1 is like about here. All right, so we know therefore that we have had our two x intercepts. Now the next thing that I need is in fact the minimum point, and so the minimum point in short form here is a combination of this number inside the bracket and this number outside. Now a better way to put it here is that to say that the min or max value, pardon me here, let me just give myself some space. So I can just go right up here and I can write that min or max value is in fact equal to negative h comma k. So once I know what the h value is, I just take the negative of that value. Now we had established that h is in fact minus 3. And so the negative of minus 3 is positive 3. So right away I know that the positive 3 is my axis of symmetry. So I know that this is 3 right here. So I know that the graph basically is at this position here. This is my halfway point of my graph. Now, as to how far I go down, that is basically going to determine by the value of k. And we had calculated that k is in fact -5. So I know that here, so this is -1, -2, -3, -4, -5. I already know clearly that my graph will not go beyond this point here. And so now that I have my minimum point, which is the intersection of, say here, I know therefore that the most reasonable sketch that I can come up with for this graph here is that, in fact, let me just zoom out here for you. It's going to, basically, the graph is going to come down, say, through 31. It's going to pass through 1.9. It's going to come all the way down to the minimum point. It's going to turn. It's going to bend up and come all the way through 4.1 and come all the way up like that. All right. And that's going to be like a decent sketch of our quadratic curve. And that's what you need to go through in order to get the answer to this type of question. So I hope that made it a little bit clear, maybe a bit much, but definitely check out my tutorials on a weekly basis to see if you see a topic on this on my channel. All right, currently at making this video, there is not an available video for completing the script, but I'll try to go out on a limb and make that tutorial for you to give you a more detailed breakdown version of how to find these values here. All right, beautiful. Let's continue on to the past paper here. It says state the equation of the axis of symmetry. And so the axis of symmetry is in fact when x plus h is in fact equal to 0. So we know that, well, sorry, it says when x plus or minus h is equal to 0. Now, if we go back in our bracket here, we recognize that inside the bracket here is where you find x plus h. So therefore, we're looking at saying x minus 3 is in fact equal to 0. So the equation then is going to be x equals 3, which is kind of like basically the line that I drew on my graph here. This broken line here represents my axis of symmetry. But the equation of that line is in fact x equals 3, and that's what CSEC is looking for. All right, so that pretty much kind of sums up what they sent for functions and relations for this particular exam paper. Definitely keep watching or rewatch the video if you want a little bit more clarity on some of the steps that we're taking. All right, but we have much to complete in this video, so let's just then go on to question 9. Now, I also made an attempt to actually do this question in the latter part of the previous upload. That is in fact part 3 of the video, but then I didn't feel like I gave you the more concise steps. So I'm going to try to make my steps very concise and to the point without going into too much theorems. I felt like I gave a bit too much theorems for you to get to your answer. So I'm going to try to make this as simple as I possibly can. All right, so here we go. Now, what we're looking at is, it says here that K, L, M, and N are points on the circumference of a circle. Now, let me pause here. This seems to be a very traditional sentence that CSEC starts off most of the circle geometry question with. And hopefully, when you're doing the particular exam that's coming up for you, when you see this sentence here, already that's a clue given to you by CSEC. They're telling you right away that if 4 points are on the circumference of a circle and they're connected, then what you're looking at therefore then is what is known as a cyclic quadrilateral. So there is in fact, in that diagram below which you're looking at the moment, you will find that there is a quadrilateral that is inscribed inside the circle. And so therefore we can see here that this is K, this is N, this is M, and this is L. And so your geometry is going to play an important role, because already in the first sentence, I know that there's a theorem that speaks about the opposite angles in a cyclic quadrilateral. It is said that they add up to 180. So later on, that theorem might play an important role. The next thing it says here is that xy is a tangent to the circle. So I know right away that a bit later from now, I know that my tangent theorem my tangent theorem is gonna come into play. Now I did in fact did a tutorial on the first 5 rules or the first 5 theorems on circle theorem, so you definitely want to check that video out. I'll pin a link in the description. Check out my tutorial on circle geometry, the first 5 theorems, and I in fact also have a video that goes through a series of these types of questions, so do also check out that subsequent video as well in a time convenient to you. So already I know that later on this tangent is going to play a role. Now it also says here that angle LKY is 48 degrees, which we can see here. So angle LKY, so LKY is 48. It also says here that MKO, this piece of angle inside here is 12. And then of course it also states here that angle XKN equals 56, which we can see right here. Now, in my honest opinion, remember that this particular video here is not necessarily to just give you the answers and how I got to my answers. It's to really guide you through a thought process, some of the things you ask yourself. Now, in my honest opinion, I feel like this particular type of question challenges students when they are unable to dissect the diagram. You have to be able to look for certain key things inside the circle. Now, some of the key things that you have to look out for is stuff like if a radius meets a tangent, or if a diameter meets a tangent, or do you see any triangles? Do you see any isosceles triangles? These are some little quadrilateral theorems, some little theorems that you have to look for. Triangle theorems, quadrilateral theorems, you know, tangent theorems. If you have to be familiar with your geometry theorems. If you're not familiar with them, then this topic might be a challenge to you. Now, here, let's have a look at what they're asking us to find here. It says that we should find the value of angle KOL. So this means then that the angle that we're looking for is in fact at the letter O. So angle KOL, and you're to give reasons for each step of your work. So I'm going to take my time here. I'm going to highlight the angle KOL. And so the angle is going to be right in this section here. Now, when I look at this angle, I can immediately see that this particular diagram here is a triangle. So already I know that I might have to use a triangle theorem. Now, which one of them am I going to use? Well, one thing I do note here is that if you look closely, you'll see that OK is a radius. So I'm going to mark that with a line like that. And you can see also that OL is a radius. And one of the theorems, one of the first theorems that you're going to learn about in my circle theorem video, which a link is pinned in the description, you will find that the theorem explains that 2 or more radii of a circle are basically of equal length. So therefore then, since this side is then equal to that side because of that theorem, then it therefore means that the triangle that you're looking at is in fact an isosceles triangle. So therefore then, this angle here plus this angle here, they are equal. All right, that's one thing that I know for sure. So I know that these two angles here are equal. Now, the only way to find KOL is to in fact find these two angles here. Now, how can I find this angle? You also look carefully, you will realize here also that since OK, the radius, connects to the tangent, then a radius is drawn perpendicular to a tangent, which basically makes this angle here 90 degrees. So if the angle that we're looking for combines with 48 gives us 90, then it therefore means that angle that we're looking for is in fact, say here, 90 minus 48. So that angle therefore is OKL is therefore then equal to 90 minus 48. And that calculation there is as a result of the radius being perpendicular to a tangent. He said that we should give reasons for our answer. So because the radius is perpendicular to the tangent, we can therefore subtract that 48 from the 90, and that will therefore gives us an answer here of, say here, 42 degrees. So that means this angle right in this position here is in fact 48 degrees. And therefore this...
Alright, hey guys, so I made a little error here by writing 48 degrees when I should have actually written 42. I'm going to make the corrections in my calculation in just a few seconds. So again, I do apologize for that. Sometimes when I'm actually teaching, I do talk a little bit faster than I write. But now, of course, during the editing, I'm always going to be able to make the necessary corrections. So thank you so much for leaving their comments down below for that correction. The angle is actually 42 degrees, okay?
Section here to be equal to, say here, 84 degrees. So therefore this angle here is in fact 84 degrees. Again, the statement for this would have obviously been that the sum of the angles in a triangle are supplementary. Supplementary means that they add up to 180 degrees. All right, or you could just simply say that triangle KOL is an isosceles triangle, hence base angles are equal. That could also suffice as a geometrical reason. All right, so that basically answers this particular question then. All right, so we could write our reasons down here as I did not even see the space for the working out. But let's then move on to the next question. We are to find the value of each of the angles below. Now, one of the things that I've explained to many of my students that I teach live is that when you're finding an angle, when CSEC names an angle with 3 letters, then the angle is located at the letter that is in the middle of the 3 letters. So LMN, the angle is at M. Now, many angles can be formed at the same point. So you must be able to find the start, find the end, and find where the start and the end intersect. And then that will create your angle. So for example, here, angle LMN is therefore then, let's see here, let's go on our diagram. So we have LMN. Notice that I have L here. Okay, so I have L here and I have N here. So when L and N meet at M, we basically form all of this angle right here. Now, how would I find that angle? Now, it basically, and if you look again here, say carefully, you'll recognize again that this particular quadrilateral is going to come into play again. Because now that angle that we're now looking for is now basically an angle within that quadrilateral. And one of the theorems that comes with finding an angle inside of a quadrilateral is that it says that the opposite angles are in fact supplementary. So this angle over here that we're looking for, plus all of this angle here, all of this angle right here adds up to 180. So now once I can find all of this angle, which is inclusive of this piece right here, then we can easily calculate our answer. Now let me just zoom up a little bit more here for you as best as I can. There we go. Now if you look that the 56 degree and the angle that we're looking for along with the 48 basically adds up to 180, because in fact XKY is a tangent, which is a straight line. So the 56 plus the angle that we're looking for plus the 48 on the outside sums to 180. So already I'm going to just go ahead and write my first statement that NKL, let me just go down here. So first step is to say angle NKL is therefore equal to 180 minus 48 plus 56. So that's going to be 180 minus, say here, that's 96 and that's 104. And so therefore then, let me just double check, 50 and 40, that's 90, 98, that's 104. So 104 away from 180 gives me 76 degrees. And so therefore then, this angle right in the center that we're looking for is in fact 76 degrees. So now that we know that this angle here is in fact 76 degrees, I know therefore then that I can just subtract the 76 from 180, and therefore that tells me, say here, the angle over here. So therefore my concluding statement is that therefore angle LMN, which is what they're asking me for, angle LMN, so therefore then, okay, so therefore then angle LMN is equal to 180 minus 76, pardon me, not 74, 76. That's therefore equal to 104 degrees. And so the reason for this calculation is that opposite angles in a cyclic quadrilateral are supplementary. Okay, are supplementary. Hope you guys understand that little scribble there. It meant supplementary. So that is how we'd end up finding that angle on that side of the diagram that you're looking at, say all the way over here. So all of this angle here is 104 degrees. All right, that's beautiful. So therefore then, that is it. All right, fantastic. Now let's move on then to the next question. Angle KLO. So let's go for that. Let's scroll up here. Angle K, and then we have to go down to L. So go across to K right here, L, and go back up to O. We inadvertently found that the angle is 48 degrees when we try to find angle KOL. So some of the work has already been done for us here. So we know then that this KOL here, angle KLO, pardon me, is equal to 48 degrees. And the reason why we know that is that triangle KOL is an isosceles triangle. And the marker, the examiner, will already know that once you make such a statement, then you therefore then found out already that that is 48. All right, you could therefore say because the radius meets the tangent at 90 degrees, then you're going to take, say here, the 48 from, is it 48 or 42? Let me just double confirm on that. It is in fact 42 degrees. So it is 42 degrees. I think I actually made an error here. So this was not supposed to be 48. I think I got a little bit confused when we did the calculation here. It was supposed to be 42. So when I said 2 times 48, it should have actually been 42. And then this should have been actually 84. And then this should have actually been 96 degrees. So this should have been 2 times 42, which is 84. And then, of course, 84 from 180 gives us 96. So this angle right here is in fact 96 degrees. So sometimes you have to kind of recheck it, guys. Okay. And let me just get back some of my lines here. All right, so this should have actually been 96 degrees instead. Hopefully that did not affect any of my calculations after that. So that's 96. Okay, and we have a reason there. All right, there we have it. So we're good to go. So therefore then KOL is in fact then, as opposed to being 48, it is in fact 42 degrees. And again, the reason doesn't change. It is in fact because triangle KOL is isosceles. So therefore we see that these angles are equal. All right, so next we're looking at angle MLK. So angle MLK, let's scroll up here. Angle MLK, where is that? So angle MLK, that is all of this inclusive of that say here 48, so it's angle MLK, all of this inclusive of the 48 here. Well, in this case here it is in fact 42. Alright, so it is supposed to be in fact 42. So the angle we're looking for is inclusive of this 42 degrees that we have here. So now all I need to know is to find a way how to find this angle over here. So we're looking for all of this angle here inclusive of the 42. So I need to find this angle right in here. Now it's a little challenging to find that angle, right? So what I'm going to be doing is that I'm going to be using my tangent theorem here. And my tangent theorem states that if I have an angle that is created between a chord and a tangent, then that angle is going to be exactly equal to the angle that is created by the chord in the alternate segment. So this 48 degrees here, this chord here, KL, created an angle all the way up here. So this angle right in here is in fact also 48. So let me just go ahead and write a statement for that. So we can name this angle here an inadvertent angle that we have to calculate. So it is KML. That's our statement. That's our starting statement. So angle KML is in fact equal to 48 degrees. And that reason is simply because the angle between a tangent and a chord, don't know what word is that I just spelled, guys. So the angle between a tangent and chord is equal to the angle in the alternate segment, in the alternate segment. All right, so that would be the geometric statement for that. Now, once I've calculated that angle of 48 degrees, that angle is going to be brutally helpful, because now that angle is 48, I then already know that this angle here is 48. This angle down here, we can this angle, this piece below the 12 here, we know that all of it is 42, and I've already calculated 12 out of it. So now that this little piece here in here is actually equal to 30 degrees. So that 30 plus that 12 is equal to that 42. So this angle in here, this green triangle, is 30. So now I have 30. I have this angle of 48, and I have a partial angle here of 42. So therefore then I could then add up all of that and take it from 180. No, or I could just simply add the 48, which is what I'm doing. I'm going to be adding the 48 degrees here and this 30 degrees that I've just inadvertently calculated, and take all of that now from 180, and I'll get the full angle that I'm looking for. So we have a couple of statements to write here. From triangle KML, all right, so we can just, instead of just stating the triangle, we can say angle KLM. So let's scroll down here. So we can go ahead then and say angle K. Oh, I think I'm a little bit confused here, guys. Hold on, let me just get my triangle again. My digital, I'm not used to this new digital device that I have. So angle KLM. Okay. So let's go here. All right, so angle KLM, which is the angle we're looking for, will be equal to 48 plus 30, and take that from 180. So KLM is equal to 180 minus 48 plus 30. So that's 180 So that's 180 minus 78. And that's therefore equal to 102 degrees. All right, and that is because of the interior angles, the interior angles of a triangle theorem. So interior angles of a triangle are equal. All right, there we go, guys. All right, so just bear with me here, guys. This new platform that I'm using to make the videos for you is a little bit challenging to navigate when I'm writing, and I don't have a lot of space. I have to be scrolling up and down, so forgive me if there's a little bit of pause during my explanation or a little bit of cut during my explanation. All right, just trying to make it as clear for you to follow. Now here, say we're looking for K and M. So let's go back up here, K and M. So let's look at K and M. So that is K here, N up here, and M. So we're looking for this angle here. And that's easy because, as we said earlier, that the opposite angles in a cyclic quadrilateral are supplementary, and we just found this angle here to be 102 degrees. And it is directly opposite to the angle we're now searching for. So we can just get straight to the point and say K and M. So angle K and M, that's going to be equal to 180 minus 102, and that's equal to 78 degrees. And the reason for that is that opposite angles in a cyclic quad are supplementary. All right, hope I'm not over explaining myself. All right, my teaching style is based on the type of students that I do teach. So a lot of the times my students are having to learn these concepts within a very short space of time. So this is how I have to get the lesson across to you guys here who are watching this video. So hopefully it's helpful, and if it is, again, do not forget to leave your comments down below and hit the like button. Now we're going to be finally moving on then to the trig part of trigonometry here, the whole cosine, sine, and tangent ratio and all those fancy stuff. So here now we're looking at E, F, G, and H are 4 points on level ground. E, F, G, and H are 4 points on level ground. Okay, noted. The diagram below gives information on the distances and angles between the points. So we're looking at, say here, this is a north line here, that's a north line here. We have 5.3 meters here. We have an unknown angle here. We have a side over here, which is 11. We have 6.9 meters. Point F, G, H, and E. All right, so I've seen all of those. All right, there's not much clue given up here. So let's scroll on and see what they want us to find. We're to show that the value of X is 29.5 degrees corrected to 1 decimal place. So we're to show that this angle is 29.5 degrees. Now, in order for us to show that, they're basically telling us that the angle is in fact 29.5, but we have to show how that answer was derived. Now, one of the things that I like to look for when I see trig, the very first thing that my brain tells me is that I need to look to see if I see any potential right angle triangles. If I see any right angle triangles, already I know that I may have to be deciphering between the cosine, the trig ratios, which is sine, cosine, and tangent, or I need to be looking at the Pythagorean theorem. If I don't see any possible right angle triangles, then it means then I'm going to be thinking about two formulas, which is sine and cosine rule. Again, a link will be pinned in the description of this video to where you can find how to apply the sine and cosine rule, which was done a few months ago on my channel. So now I don't see any right angle triangles. Now I'm guessing that maybe I need to use the cosine or the sine rule. Now when I observe this triangle over here, as I'm going to be zooming up for you now, say here, I realize that this X here that I'm looking for is in fact in a triangle that is non-right. Evidence of any 90 degree here. Now, the cosine rule is applicable here because we use the cosine rule in two different scenarios. When we are given an angle between two sides or when we're given all three sides. Now already I know that the cosine rule is in fact c squared is equal to a squared plus b squared minus 2ab multiplied by the cosine of the angle that we're in fact looking for. Again, you can check out the tutorial video on my channel about how to apply this formula. So c squared is in fact going to be the side that is facing the angle we're looking for. So in this case here, my c is going to be 6.9. So that's 6.9 squared. A and B are going to be the other two sides respectively. So that's 5.3 squared plus 11 squared minus 2 times 5.3 times 11, and obviously multiplied by the cosine of the angle, which we do not know in this case. So let's grab our calculators out. 6.9 squared is in fact 47.61. And that's going to be equal to 5.3 squared. That works out to be 28.09. And 11 squared is 121. And that's going to be subtracted. We're going to subtract 2 times 5.3 times 11. That works out to be 116.6. Cosine theta. That's joined onto it. So 47.61 will be equal to, when I add 28 to 28.9, 28.09, pardon me, 28.09 to 100, and see here 21. When I add those together, then I'm going to get 149.09. And I'm going to subtract 116.6 cosine theta. Now the objective is to get cosine theta to be positive. So therefore then I'm going to transpose the negative 116.6 cosine theta to my left, because I need my cosine theta to have a positive sign in front of it. So I'm going to have 116.06 cosine theta. Remember that these two numbers are attached. These two, this constant here and this variable here, cosine theta, they're attached. And so therefore, bringing that to the left forces me to bring the 47.61 to my right. So that's 149.09, subtract, say here, 47.61. So subtracting then 149.09 minus, say here, 47.61. That works out to be 101.48. And that's going to be equal to then 116.06 cosine theta. Now I need to isolate cosine theta by dividing both sides of the equation by 116.06. So that's going to be 101.48 divided by 116.06. And so cosine theta then works out to be 101.48 divided by 116.06. And that gives me an answer here of 0.874. Now, if you go on your calculator as you're watching this video and you press the shift button or the second function button that you can find at the top left-hand corner of your calculator, and then you press the cos, you should see cos raised to the -1 coming up. So theta then is equal to cosine raised to the -1 of the value that you're looking at here. And if we have done our calculations correctly, it should show that the answer is 29.5. So that is shift cosine 0.874, and if you get 29.07 or thereabout, then of course they say round it off. They said that theta here is equal to, well, on my calculator it is telling me that it is 29.07. all right, so it is very, very close to 29.5. I'm not sure why I'm not getting the exact value as requested, but it could be a case where maybe I needed more decimal places here. So it could be anything really, but it's very, very close to the answer requested by CSEC. It's within a range. So this would be an acceptable estimation for the angle. So that we have proven there. All right, so let's put that information here on the diagram. We know that X is in fact 29.5. Now we're gonna go down to this section then of the paper, and it says that a vertical tower, GT, a vertical tower. Normally when you see that word vertical, you know right away that a 90-degree is going to be involved. So a vertical tower, GT, is constructed at the point G and is pivoted to the ground at the points E, F, and H using pieces of wires. Let's just look at that first of all. So it says that a vertical tower GT is constructed at the point G. So a vertical tower GT, vertical tower. So right away then, I'm looking at from the point G, a vertical tower has been constructed. Let me just remove this 29.8 to get a visual of this. So this is 29.5 degrees. So when it says a vertical tower, what we're looking at then is in fact, say here, let me just use a different color. A vertical tower. We're looking at saying draw a straight line up like that. All right, so that's the vertical tower GT. So T would obviously be in here. So that's a vertical tower that's constructed at G. All right, so that's the vertical tower. And then it went on to say something that, let's see here, guys, constructed at the point G and is pivoted to the ground at the points E, F, and H. E, F, and H. So E, F, and H. So it is pivoted. So what we're looking at then is that a line basically connects this to this. And we know that it's a vertical, so we know right away that that angle there is 90 degrees and it's pivoted to the ground. So basically then we're looking at a right angle triangle being constructed on this platform here. So let's just take this out here. Let's just take this diagram then. Because what helps is that once you can interpret the question, then you can draw your separate diagrams to help you. So we're looking at, say here, this vertical tower that was constructed at G, and then it was connected, then say here to F, all the way down here. All right, and we know that this is 90. Let's see what it then goes on to say. It says that the angle of elevation of the top of the tower T from the point F is 31. So from F, this is 31 degrees. So the elevation angle is the angle looking up at T, and that is 31. All right, and let's see what other information was given to us here. It says, what is the length of the wire? What length of wire was used to secure the point T to F? So we're looking for this side here, that is X. All right, so we only have an angle and an unknown side. Let's look back at our main diagram to see what other information is up there. Vertical tower GT. So, okay, GT. So could it be this? All right, so I think what we're looking at here is the base of the triangle is actually 6.9 because the vertical tower was connected from G and then connected to F. So already we know that, say here, GF is 6.9. Not sure how that missed me, but just kind of rereading the question here. So we know that right here is in fact 6.9. All right. So therefore then, this is 6.9. So therefore then we can go ahead and use that's the hypotenuse. This is the angle, so that is my opposite. This is my adjacent here. So therefore I can use the cosine ratio here. So cosine theta is equal to adjacent divided by hypotenuse. All right, because that's my hypotenuse, is my adjacent. So the cosine of 31 degrees is equal to the adjacent, say here, is 6.9, and the hypotenuse is in fact what we're looking for, which is x in this case here. So the cosine of 31, that is 0.857, and that's equal to 6.9 and divided by x. When the unknown is at the bottom of the equation, we can therefore just take the x and put it up here and have the 6.9 being divided then by the 0.857. So we say 6.9 divided by 6.9 divided by 0.857, and it will end up with a result here of 8 centimeter, 8 meters, 8.05 to be precise. That's 8.05. I think our measurements were in fact meters, so it is 8.05, say here, meters. All right, that is how you find the length of the wire that connects the top of the pole, the top of the vertical pole GT to F. Okay, now we're then looking for finding the bearings of E from F. The bearing of E from F. Remember that a bearing is measured in a clockwise direction. So we need to draw a north line at H, and then follow the angle in a clockwise direction until we meet at the line leading us to E. Now, it seems as if they have given us the bearing. Okay, so they in fact they have told us here that the bearing of E from H is 228. I initially thought that they were asking us to calculate it. So they're telling us that it is 228. Then we are required to find the bearing of H from E. So they give us the bearing of E from H, but we are to find the bearing of H from E. So let's go on our diagram then. So we know that E from H is 228. So E from H, let's go ahead then and kind of just clear this up a little bit. E from H, so I'm going to need some sort of north line here to help me. So E from H then, so where we have E, where is E? This is E here, from H, so this is my north line, so come around like that, all the way around here, that's going to be 228, that's what you're saying. All right, that is 28. All right, so if that is 228, our requirement then is to in fact find the bearing of H from E. So H from E, so north line here, H from E. So H from E, we need this outside angle right here. That's the bearing that we're looking for. Now, this is a little tricky, so you guys have to pay very close attention to what I'm going to demonstrate here. And I don't have a lot of space, guys. Now, since this is a north line, if I were to extend, say here, a line, an auxiliary line here, and call it my south line, then already I know that whatever this angle is from the south to here is going to be equal to, say here, the angle down here, because of the alternate angle principle. When north and south is parallel, then you're looking at forming a Z angle. So right here is going to be equal to right here. Now please note that the 54 is in fact what we want and a little tiny piece over here. All right, so that 54 can be a little bit tricky. It might be misled to think that the angle down here is 54. Now, to find this angle inside the Z here, this Z that I've drawn with my green line, to find this angle, I know that the complete angle is 228. And I know that from north to south is 180. So this piece of angle in here is going to be 228 minus 180. So if you go down here and we write that, name that angle then, let's give it a name. This is S here. So I know that this angle that I'm looking for is in fact EHS. So EHS. So angle EHS is equal to 228 minus the degree from north to south. And then therefore then that works out to be 48 degrees. So that angle in that little section of the diagram there is in fact 48. And that is as a result of, say here, angles at a point on a straight line measures 180. All right, so I don't think I need to write a statement for that one. So I can therefore then conclude that the bearing, so H from E, is in fact equal to 48 degrees, and that is as a result of the angles being alternate. So alternate angles are equal. Again, 6 is a little bit stingy on the marks there. I thought that was a lot of thinking for just 1 mark, but it is what it is. It's 1 mark. So that's what we had to do to calculate that angle in here. So let's go on our main diagram now and then write in that 48 degrees here. So this is in fact over here 48, and then therefore then this angle inside here is in fact also 48 degrees. So right away now, if I need to find this, I can just take 48 away from 54 if I need to find it later on, that little piece right in here, right here. Okay, so let's hold on, let's see if we're going to need that. Remember that this x already we've proven is in fact 29.5 degrees. All right, so that is the bearing of H from E. Now we're looking at the bearing of G from H. So G from H now, we need to draw our north line at H and head towards G. So G from H. So from H again, now we already have our north line, but then we're going around to G. So we're looking from H to G here. This is that part right there. All right, that is inclusive of that 29 degrees, 29.5 degrees. Now, how can we do this? We know already that from here to here includes our 29.5. So we don't know the full angle coming around from north to this position here, G. Now, as I said, this angle in here might be very useful. So this piece of angle, hopefully you guys are following that little piece right in here, is in fact going to be 100 and it's going to be actually 54 minus the 48 that we just calculated here. So that's 48. So that little piece of angle right in here is going to be equal to, say here, 6 degrees. So this little piece right in here, let me just shade it for you right here, is in fact 6 degrees. All right. So now that I know that angle is 6 degrees, I know that the complete angle coming around all the way here is in fact, say here, 180. So all of this angle is from north, come all the way around to this constructed auxiliary south line that I drew is 180, and I know that a part of it is 6 degrees, so I can find the rest. So I can just simply scroll down to my section here and I can say G from H is in fact 180 minus 6 degrees, and that's equal to 174 degrees. That reason would have obviously been that north to south equals 180, so north to south equals 180 degrees, and my additional calculation would have been that 54 take away 48 degrees would have been equal to the 6 degrees here. We could actually name that angle. All right, we could name that angle, that 6 degree angle that we zoomed up here, we could name that angle SHG. So angle SHG, so angle SHG here, SHG is equal to 54 minus 40, which is 6 degrees. And so therefore G from H would have been equal to the 180 minus the 6 degrees equal 174. All right, angles at a point in a straight line measures 180. All right, you could do that. So as I said, guys, circle geometry can be very, very tricky. You really have to be able to see in between diagrams, the angles and so forth. But as I said, if you want some real practice on it, check out my tutorials on circle theorem it can be quite helpful. All right, so this was a tricky one by CXC. Definitely put a number on this one. Definitely the difficulty level of this question I would say is about 6 or 7 in terms of what a student needs to know. So definitely, hopefully that little demonstration there helped you out. So we're going to be moving on to the last question then of this particular paper here. We are just approaching an hour. It did take some definite detailed work, to get to this point. So hopefully you have liked the video and you are in fact learning as we go along here. Now in the diagram below, O is the origin. O to E is 2 times EF. And M is the midpoint of EG. The vector OG measures C units and the vector OF measures D units. Let's try to interpret what this sentence is saying here, this instruction here. And vectors is also another challenging topic for many math students. So hopefully this might be helpful. So first it says O is the origin here. So that's 0, 0. And O to E, that's O to E, is equal to 2EF. So that means this ratio here is a 2 to 1 ratio because it takes 2EF, so it takes 2 of this distance here to make 1 of this distance here. All right, so it's a 2 to 1 ratio, we get that. All right, so O to E is 2 and E to F is 1. So it takes 2EF to make 1 OE. All right, fair enough. M is the midpoint of EG. So when a point lands in the middle of a line, it says that this segment of the line is equal to this segment of the line. That's what we know for sure. And it says that OG is C units. So O to G is C units. Let's put our C units here. And O to F here, O to F, all the way up here from O here down here to F all the way up here is in fact, say here, D units long. All right, so I know that from here to here is O to F. So our vector arrow should be going that way, and our vector arrow for this one is going that way, O to G and O to F. All right, noted. Let me just clear this up a little bit here so it doesn't become too confusing. All right, so there we go. We have a 2 to 1 ratio here. All right, we got you there. All right, beautiful. So now they're asking us then to calculate, say, or find in terms of C and D, in the simplest form, FG. So F to G, then we have to use what is known as the triangle laws of vectors. So if we want to go from F to G, we have to go from F back to O, and then we have to go from O to G. So now to find this, then we are going to simply say, using triangle law of vectors, we're looking then at F to G is in fact F to O plus O to G. So F to O will be the inverse of OF. So since O to F is D, then F to O is minus D. It's the inverse vector. And then of course O to G, clearly we were told that O to G is C units. So therefore then that is minus D plus C. And that's it. That is our answer. So F to G is in D plus C. That is our result. Let's just put that in a little box here. All right, so it's not really challenging in terms of getting the result, but you must be familiar with the concept of triangle laws of vectors. Now let's look at finding E to G. So from E to G is right here. So let's put our arrowhead here. So E to G, once again, is the same procedure. We're going to go from E to O and O to G, or you could go E to F and F to G. whichever one you want to do. I'm just going to go with what was already given to me. It doesn't really matter which direction though, as long as I end up back at the ending point. So I'm going to take e to g is going to be e to o plus o to g. E to o plus o to g. Now we know that there was a relationship between EO and the whole entire vector OF. We know that the whole length is D. So already I know that from here to here is going to be 2/3 D. It's going to be 2/3 D. It's 2/3 the whole entire line. So this section here from E to O, remember the vector is going this direction, but we are forced to go that direction. So we know that O to E is O to E compared E to F is a 2-to-1 ratio. So I know that the total parts of the line is 3 and O to E is 2 out of that 3 parts. So it is 2/3, but it's negative because I'm going in the opposite direction of the vector. So E to O is negative 2/3 D. And O to G, as you would have already seen, is in fact C. So that's negative 2/3 D plus C. Or if you do it the other way, you might end up with C minus 2/3 D. Same answer. Alright? And then O to M then. O to M, we must connect a line from O to M, obviously. So from O to M here, put on our arrowhead here, is again another triangle. O to M is going to be from O to E, which is in the same direction of the vector, which already we established just moments ago that O to E is 2/3. Why 2/3? The ratio is 2-to-1. So when I add 2 plus 1, this whole entire line OF has been split into 3 parts. And so because the ratio is 2-to-1, then it simply means then that OE is going to be 2 out of the 3 parts here. We are going in the same direction of the vector. So O to E is going to be 2 positive 2/3 D. And notice then that EM is going to be half of EG, because M is the midpoint of EG. So EM is going to be half of EG. So then I could write a statement here and say that O to M is going to be equal to O to E plus E to M. So O to M is going to be equal to O to E plus E to M. And O to E is going to be 2/3 D. Because up here we were looking for EO. So EO was negative 2/3 D. Obviously then OE is going to be positive 2/3 D. And then of course EM, we just established that that is going to be half the length of EG. And see, we have here EG, which was just calculated. EG is going to be negative 2/3 D plus C. But since, oh pardon me, is this EG? Yes, this is in fact EG. EG we had worked out to be negative 2/3 D plus C. So since EG is negative 2/3 D plus C, then it's going to be half negative 2/3 D plus C. So then this is 2/3 D plus a half of 2/3 D is going to be 1 times negative 2 over 2 times 3. Oh well, we can just cancel the 2 2's here. So a half of negative 2/3 is negative 1/3. So we can just fix that up right away. So a half of 2/3, this 2 here cancels this 2 here already. So this 2 here cancels this 2 here, so we're left with negative 1 over 3D. So negative 1 over 3D. Alright, so that's a half multiplied by this gives us negative 1/3 D, and the half multiplied by C, we have to use the half to distribute inside. So half of this is negative 1/3 D, and half of C becomes a half C. Now we have to group like terms here. We have 2/3 D, take away 1/3 D. Well, that's kind of straightforward. The LCM, the denominators are the same, so 2 take away 1 is in fact 1/3 D plus a half C, and that is your result. All right, vectors can be a little bit complicated at times, but if you have any knowledge about triangle laws of vectors, definitely you'll realize that it's not as challenging as it appears to be. All right, I'm not sure if at the point of you watching this video I would have already made a vectors video or series of questions, past paper questions on vectors. If it's available, you can check my vectors playlist. If not, then hopefully upon watching this video I would have already posted that say here video on that. All right, so look out for my vectors review tutorial video. All right, and then now just to wrap up the paper here, as we're a little bit over an hour, the matrices P, Q, and R are given below in terms of the scalar constants A, B, and C. So we have A here, we have B here, and we have C here. It says, given that the vector P, the matrix P plus the matrix Q equates to the matrix R, our task is to find the values of A, B, and C. All right, so we're going to write down our matrix P here, which is 3, -9, A, 7. We're going to add that then to matrix Q, which we have here to be -1, B, -4, 1. And we're going to equate that then to the matrix R based on the conditions given to us here. We're going to equate that to the matrix R, which is C, -3, -4, 8. So now, when we're adding matrices, we know that we have to add corresponding entries. So the first gets added with the first, the second gets added with the second, the third gets added with the third, and the fourth gets added to the fourth. So if I add 3 plus -1, I'm going to end up with 2. If I add -9 to B, I'm going to get -9 plus B. You cannot add unlike terms, so we just merge them together. If I therefore add A to -4, I'm going to end up with, say here, A take away 4. And of course, when I add 7 to 1, I'm going to end up with, say here, 8. And so that sum of matrix is then equated to the matrix here, C -3, -4, 8. Now we're going to compare coefficients. We're going to compare entries. It means then that this 2 here is going to be equal to C, because if two matrices have equal entries, then it means that the matrices are in fact equal. So this 2 here would be equated to C. This -9 plus B is going to be equated to -3. This A -4 is going to be equal to -4. And this 8, obviously, we had worked it out perfectly to be equal to 8 then. So we know we're on the right track. Now to wrap this up then, our first value here is that C is equal to 2. So right away we're gone, that C is equal to 2. Our next equation here shows us that -9 plus B is therefore equal to -3. So we can solve this very simple equation, bring the -9 over, we end up with B being equal to -3 plus 9. So B then is equal to, say here, 6. That's so. And then of course our next equation here is that A -4 is equal to, say here, -4. So if I bring this -4 over here, I'm going to end up with A being equal to -4 plus 4. It so happens that A is equal to 0. All right, and that is my third result. So A is equal to 0, B is equal to 6, and C is equal to 2. This particular problem was possible because we know the concept of equal matrices. All right, so hopefully you guys got a hang of that. Now it says here that we are to solve the following pair of simultaneous equations using a matrix method. And so there's only one matrix method that exists for simultaneous equation. So we're not going to be using the elimination method or the substitution method. We're going to be using the matrix method, which therefore clearly states that A multiplied by B equals C, equals C, where B is our unknown matrix. Then that means B is equal to the inverse of A multiplied by C. That is the shortcut method. Now, I do not have a matrices tutorial playlist available, so you're just gonna take my words for it, guys, and look at other circumstances, other situations where I might have videos explaining matrices questions. But at the moment of making this video, I do not have a playlist on matrices. Hopefully I can get to that soon and very soon. But here we go. We're gonna set up the equation here in the form AB equals C. So therefore, to get the matrix A, we're going to take out the coefficients of the equations. So this is 5, negative 2, 2, 3. Then the matrix B is obviously going to be the values that we're looking for, X and Y. And then we're going to equate that then to the matrix C, which is representing the solutions to the equation 44 and 10. And so that is the setup. So of course, then as I stated that since the matrix B is the unknown matrix here that we're looking for, then XY is going to be, say here, equal to 5, negative 2, 2, 3, inverse, that's minus 1. And then we're going to multiply that by 44, say here, 10, 44, 10. So then our knowledge on inverse of a matrix is applied here. Now to find the inverse of a matrix, we know that in this case here we're looking for B. All right, so we're looking for A inverse. Let's call this matrix here A. So A inverse is equal to 1 divided by the determinant of A multiplied by the adjoint of A. So determinant of A is equal to the formula AD minus BC. So in this case, A is our first entry, which is 5, multiplied by our last entry here, which is 3. We're going to subtract that from our second entry here, which is negative 2, multiplied by C here, which is again here, say 2. So 5 times 3 is 15, and negative by negative is positive. 2 times 2 is 4, so we end up with a determinant here of 19. Bear in mind, guys, that I'm working this paper with the assumption that you guys have already been through the topic of matrices and you have an idea. All right, so if you have not done the topic of matrices, then this might look a little bit foreign to you. All right, so here we go. Good. So now that we have the determinant of A, we need to find the adjoint of A. Some teachers will say that this is where you diagonalize the matrix, or other instructors will say this is the cofactor of the matrix. So adjoint, cofactor, diagonalize the matrix, same procedure. Now to do this then, we're going to take the lead diagonal of the matrix. Alright, so we're going to interchange the entries of the lead diagonal. So we're going to interchange those entries. So 2, negative 2, the positive 2 goes up, and the negative 2 comes down. And then we're going to change the signs of the non-leading. Okay, so pardon me, I think I made an error here. The lead diagonal. Okay, pardon me. So the lead diagonal is in fact 5 and 3. So we're going to interchange the entries of the 5 and the 3. So the 3 comes up and the 5 goes down. And we're going to change the signs of the non-leading. So we're going to change this negative 2 here to positive 2. And we're going to change this positive 2 here to minus 2. So the matrix has been diagonalized, or the matrix that is the adjoint of the matrix. So therefore then, to find the inverse of the matrix, then we're looking at 1 divided by, say here, the determinant, which is 19, multiplied by the adjoint, which we have here to be 2, negative 2, 5. Now we could go inside and put each of the entries over 19, but that's going to make the math a little bit more challenging. So I'm going to keep it in its scalar form here. And then from here now, I'm just going to use that as my inverse matrix in its scalar form. So xy then is therefore going to be equal to the inverse of this matrix, which we then just calculated to be 1 over 19 multiplied by 3, 2, negative 2, 5, and we're going to times that then by 44 and 10. You can see it's 4 marks, guys, so it's a lot of work. So now we're going to have xy, which is therefore then equal to 1 over 19, and we're going to then go row by column for this matrix here. Now 3 times 44, that sounds like 132. So that's 44 times 3, that's 132. So when we go row by column, and this is off the assumption that you guys already know how to multiply matrices. So row by column, here we go. 3 multiplied by 44 is in fact 132. And we're going to add then 2 times 10, which is 20. And then of course, row by column again, negative 2 times 44, that's negative 88. Multiplied by 5 times 10 is 50. Now by doing all of that then, 132 plus 20, that sounds like 152. So let me just go here and put my 4410 here. So I know that when I do all of that then, I know that 1 over 19 will then multiply, say here, 132 plus 20, that's 152. And then of course, negative 88 plus 50 is going to be negative 38. Alright, and that's going to be that xy is equal to this. So by wrapping this up then, we're looking at x being equal to 152. So x is going to be equal to 152 divided by 19. So that's 152 divided by 19. And that's 8. And then it works out that y then is equal to, running out of space here, guys. So y then is equal to negative 38 divided by 19, which is equal to negative 2. So those are my 2 solutions. Alright. Now it was in fact a very lengthy video. Alright. I really tried to take the time out to go through these process with you. I actually made this video for a specific group of students who are currently being prepared for the exam. Upon watching this video, you may or may not have completed the topic of matrices. If you have already, then most of what was explained here would have been a little bit clearer to you. Alright, so I hope I was able to help you in, understanding the whole entire paper, my overall analysis of the whole 2024 paper. It was really a nice paper. It really dibbles and dabbles with a lot of different areas in math that you students should have already been exposed to from 10th grade. So it really dibbles and dabbles with everything. We saw a little bit of matrices, we saw a little bit of simultaneous equations, and we saw a lot of simultaneous equation. We saw 2 really interesting questions. The circle theorem difficulty level was, I would say, it's about 6 or 7, maybe at maximum 8. The functions was nice. The construction was very simple. The worded problems in question 1, 2, and 3, they were okay. I really like the simultaneous question at the end of video number 1. The statistics was also a little bit easier than usual. The pattern question was also very nice as well. So overall, in my estimation, at first glance, the paper looked a little bit challenging, but upon just going through the paper in details, it wasn't as bad as I thought it was. So I would give this an overall 7 or 8 in terms of being a really good paper. Alright, not much challenge, but there were challenges. Alright, so hopefully you guys enjoyed the video and you enjoyed the series of breakdown forms for 2024 January paper. I really do hope that it was able to be helpful to you, and I will see you in the 2023 January resit paper as well. Alright, hopefully I can get a chance to do a lot more upon you getting these videos. Alright, so thank you so much for joining. Do not forget to hit the subscribe button below, hit the like button, leave your thoughts and comments down below, and I'll see you next time in another tutorial video. Take care. Bye bye.